Hello everyone, this is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University, Surampalem. So today I would like to discuss about the concept programmable read-only memory. Simply we call this one as a PROM. So coming to the learning outcomes, at the end of this lecture, student will be able to understand the architecture and working of programmable read-only memory. Simply we call this one as a PROM. So they will also be able to design combinational logic functions using PROM and evaluate its advantages, disadvantages, applications and in digital systems. Coming to PROM, ROM, simply we call this one as a read-only memory, is a memory device which stores the binary information permanently. That means it can't change that stored information by any means later. So that means we cannot change the data in the ROMs. If the ROM has programmable feature, then it is called the programmable ROM. We call this one as a PROM. The user has the flexibility to program the binary information electrically once by using PROM programmer. So now coming to the PROM, so this is the architecture of the PROM. So this we call it as a block diagram of the PROM. So which contains the two boxes. So simply this is a fixed end array. So fixed end array and fixed programmable OR array. It contains the fixed end array and programmable OR array. Now the inputs of the AND gates are not of programmable type. So here if we consider that there are totally n number of inputs and outputs are directly connected to the inputs of the programmable OR array. Now so these are the simply we call this one as a fixed end array. That means if we observe this fixed end array, we can simply draw or we can use a decoder circuit. If we remember the decoder circuit, so the number of inputs, if the number of inputs is equal to n, the number of outputs are 2 to the power of n. So we can take the help of this equation n into 2 to the power of n. So this is the equation for decoder, the same equation that is applicable in this fixed end array. So this same block diagram we can use for this particular first block, fixed end array. The same output, whatever the 2 to the power of n outputs that are directly given as the input to the programmable OR array. That means we can use some switches or fuses. So these are the fuses. So that is directly connected as an input to this PROM, that is programmable OR array. So with the help of this fuses, so we can implement any such a type of functions easily. So and finally we will get the M outputs here. So this is the explanation of the PROM. Now coming to this is the structure. So we can simply whatever we discussed in the previous slide. So this is the decoder. Simply the decoder is 6:4, That means 6 inputs and 64 outputs. So we know 6 inputs means 2 to the power of 6, that is equal to 64 outputs. So simply we are using the decoder structure here. That means 6 inputs that starts from A0 to A5 and outputs that is from 0 to 63, that is directly fixed. Fixed means no need to use that fuses, or these inputs are directly fixed. And coming to the OR array, this is the OR gate array. This is the OR array, OR gates array. Now it contains all the OR. So whatever the required function, these are the functions are the outputs, required functions, and each OR gate that are directly connected to the output of this decoder. So these are connected directly but with the help of the fuses. So if we connect like this, so 64 into 4, these are the 4 functions. So F1, F2, F3, F4, 4 functions and totally 64 outputs. So these 64 outputs are from decoder. So finally 256 fuses is required for this particular circuit. That means 6:64 circuit. So this is the internal structure of the PROM. Now coming to the PROM, So AND array with buffers or inverters is an N2 2 to the power of n line decoder. So we already seen that structure. And OR array is a collection of programmable OR gates. So that is also simple. So here if we observe the internal structure of the decoder, so this is the internal structure of the decoder. So this is what previously we used the block diagram of the decoder. So now you can observe the internal structure of this decoder. So this is starts from x0 to xn minus 1, that means totally n number of inputs here, and we can expect here the n number of inputs. For n number of inputs we can expect 2 to the power of n number of outputs. So after this output means the AND gate outputs are the outputs, and those are 2 to the power of n. So finally we will get the 2 to the power of n outputs. Those 2 to the power of n outputs is given as the inputs to the particular OR gates. So OR gates all are fuses. So it contains the fuses. That means inputs are fused. So these are fused, or we can use this symbol or the cross symbol. So cross symbol indicates the fuses. So this structure is completely constructed with the fuses. So if we want the output means output of the OR gates, that is F1 to FM. FM means totally m number of outputs are here. So now if we want these functions as the output, then depending on that particular functions only, the fuses are, we have to keep the fuses and we have to damage the fuses. Damage means blow out the fuses. So depending on the requirement of the particular operation, we can put or remove the fuses at the input side of the OR gate. So this is the construction of the PROM for implementation of any equation or Boolean functions. So here the 2 to the power of n inputs, and finally we will get the m outputs for this particular next second circuit, that means programmable OR array circuit. So we can realize of Boolean expressions. So we will see in the with the help of the examples. So now coming to this slide, so we can take one example problem. So implement the following Boolean functions using, so here that is given two equations, that is A and B, which contains the variables x, y, z. So contains the sigma m of 5, 6, 7. That means this is the min terms, and here sigma m of 3, 5, 6, 7, B and A. So here we can expect A and B are the outputs. So that is why we can place these two outputs at the output of the OR gates. And coming to the input side, we can expect one decoder circuit. For this already the question contains x, y, z, that means 3 inputs. So that is why these are the 3 inputs for the decoder circuit. Anyway, we call this one as a decoder, that means fixed AND gates. So if we use x, y, z are the 3 inputs, if 3 inputs are there, so 2 to the power of 3, that is totally we can expect 8 outputs. So these are the 8 outputs, starts from M0 to M7. That means these all are fixed, and we can give, these are like this. Now the functions are 2, that is A, B. Now A contains 5, 6, 7. So that means the input of the OR gate is directly connected with the help of fuse. That means here 5, that is min term M5, 6 min term M6, 7 min term M7. That means 5, 6, 7. Here the inputs are 5, 6, 7. That is our function, A function. So likewise we have to use this function. And for B, this is 3, 5, 6, 7. That means we have to use the fuse at 3, that is M3, and 5, M5, and 6, M6, 7, M7. So these are the min terms for this B expression, Boolean expression. So we can get the output of A and B like this. So finally we can construct the PROM circuit like this. So this is a simple circuit. And so x means here it is a fuse. So it is already indicated, the symbol x is nothing but the programmable concept. So we can use that fuse like this or with the help of cross mark. So any symbol we can use. Now coming to the second example, so realizing the function f1 of here already mentioned x2, x1, x0. These are the variables, and this is the boolean, that is we can simplify with the help of K-map or SOP or POS form. So this is also f2 function, contains x2, x1, x0, and contains the again expression boolean function. So now we have to realize this particular equation. So simply we can get the x1, x2, x0. So x2, x1, x0 are the inputs. Now if 3 inputs are there, again there is 8 combinations, that is 8 combinations are, we are simply following the binary combinations from 0, 0, 0 to 1, 1, 1 here. At the same time, the function f1, whatever the f1 function and f2 function are the outputs here. So f1 is contains 0, m0, 1, m1, 2, m2, 5, m5, 7, m7. So all these are min terms. So wherever that min term is there, we have to place 1 for this particular corresponding input. That means f1 is here m0. So for particular 0 combination, we have to give 1 here, and here 1 is their min term. So again for 1, the particular input, corresponding input 1, so we have to place 1 here, and again for 2 we have to place 1 here, and 5 we have to place 1 here, and 7 we have to place 1 here for the function f1. So likewise we have to again give the ones at the f2. So here f2 contains 1, 2, 4, 6 min terms. Again we have to give here, this is 1 and this is 2 and this is 4 and this is 6. So likewise we have to place 1 at the particular corresponding inputs. So now, so this is the again the structure of the decoder. If we observe, this is the entire structure of the decoder block diagram. So which contains the x0, this is the x0 terminal, and this is x0 bar terminal, this is x1 terminal, x1 bar terminal, x2 terminal, x2 bar terminal, and finally we can give all these terminals to the 8 AND gates. That means here 2 to the power of 3, that is totally 8 AND gates. If we observe these dots, dots means all are fused. That means fused means fixed. Here these all, there is no fuses here, these all terminals are fixed. So AND gate inputs are fixed. That is why we are using the decoder concept here. And finally we will get the outputs of all the AND gates. Now AND gates are, that means output of AND gates are programmable, or the inputs of OR gate are programmable. Now we know already f1 and f2 are the functions. So for this particular functions we require 2 OR gates. So for this 2 OR gates, so for function 1, so here f1 inputs are here 0, 1, 2, 5, 7. So for 0, 1, 2, 5, 7. So here we used the fuses here, and remaining all we can remove the terminals. Likewise for f2 equation contains 1, 2, 4, 6. So here 1, 2, 4, 6. Here we have to keep these fuses at the input terminals, the input of the OR gate at 1, 2, 4, 6. Remaining we can remove. So likewise we can construct any Boolean expression or Boolean equation or Boolean function, so with the help of this concept. So this is easy, very easy. Now coming to the advantages of this particular PROM. So non-volatile memory, as we know, this is a non-volatile memory because ROM contains the basic advantage, that is non-volatile memory. So retains stored data even when power is off. And simple architecture, so that means easy to design and implement in digital systems, and fast read operation, suitable for fixed lookup table applications. So lookup tables are used in FPGAs. Mostly we can observe lookup tables at the FPGA concept. So field programmable gate array concept. So that structure itself indicates one decoder, one XOR gate, one AND gate. So all this is a combination, we call that one as a lookup table. So this is, we simply shortcut LUT. So and these LUTs are used in the, that means particularly the FPGAs. So cost effective for fixed designs, that means ideal for mass production once programmed. So, and one more thing is, so this is a programmable read-only memory. So, the only thing is we can program this device once at a time. That is advantage. At the same time, that is a disadvantage also. So, coming to the disadvantage, so here what we observed, that is programmable only once. That means cannot be erased or modified after programming. So, a user can program at once in the lifetime of the PROM. So, we after programming in the particular PROM, so we cannot change the that means whatever the inputs or whatever the application in the particular PROM. So, inflexible design, because any error requires replacement of the chip. So, if the program contains any error, if we after dumping the entire equation in the PROM, so we cannot erase. So, simply we have to replace the entire chip. So, this is the drawback for the PROM. And limited logic flexibility compared to PLA or PAL. So, in previous classes we discussed about the PAL and PLA concepts. So, when compared to that one, so this is limited logic flexibility. And wastage of memory space if full address space is not utilized, because these PROMs are fixed with address memories. So, we already used that 6 into 64. So, if we don't use all these inputs and outputs, so again there is a wastage of the memory in this particular PROM. Coming to the applications, so lookup tables, as we already discussed, we call this one as a LUTs in the combinational logic circuits, and microprogrammed control units in processors. So basically these FPGAs are like reconfigurable devices. So reconfigurable means, so we can store the data, at the same time we can process the data. So that is why, so that acts as a microprocessor also. So that is why we call this one as a microprogrammed control units. This is the application. So we can use this application in that particular operation. And code storage in embedded systems, and character generators in display systems, fixed logic function implementation in digital systems. So coming to the summary, a programmable read-only memory is a non-volatile memory device used to implement fixed combinational logic functions. It consists of a programmable AND array and fixed OR array, where all possible minterms are generated and selectively programmed. PROM is widely used for lookup tables and permanent logic implementations in digital systems. Thank you.